Hi friends, today I am giving a lecture on 8 puzzle problem in branch and bound in design and analysis of algorithms. 8 puzzle problem is one of the application of branch and bound. 8 puzzle problem is one of the most important concept in branch and bound. In 8 puzzle problem, there are 8 tiles numbered from 1 to 8 on a 9 tile capacity square frame. Okay, so this is the 9 tile capacity square frame. On that square frame, 8 tiles numbered from 1 to 8. 1, 2, 3, 4, 5, 6, 7, 8. But one empty tile is called as empty slot in 9 capacity tile square frame. Now, what is the main objective of 8 puzzle problem? The main objective of 8 puzzle problem is to transform the arrangement of tiles from initial arrangement to goal arrangement. Okay, so this is the initial arrangement and this is the goal arrangement. Our main objective is to transform this initial arrangement to goal arrangement. Okay, in the initial arrangement 1, 2, 3, 4 empty slot, 6, 7, 5, 8. So this is called as the initial arrangement. Now we have to transform the arrangement of tiles from this arrangement to this arrangement. This is called as goal arrangement. In that goal arrangement, the empty slot is located at the last. That is 1, 2, 3, 4, 5, 6, 7, 8. This is called as goal arrangement. This is called as initial arrangement. Next point. There is always an empty slot in the initial arrangement. So this is the initial arrangement. In that initial arrangement, there is one slot that is empty. That slot is called as empty slot. Now this slot is called as empty slot. Okay, it does not contain any tile. Okay, next one. Legal moves are the moves in which the tiles adjacent to empty slot are moved to either left, right, up, down. Okay, now this is the empty slot. Okay, what are the adjacent tiles per empty slot? So tile 2, tile 6, tile 5, tile 4. Okay, what are the legal moves per adjacent tiles? Tile 2 can be moved to down, tile 5 can be moved to up, tile 6 can be moved to left, tile 4 can be moved to right. Okay, legal moves are the moves in which the tiles adjacent to empty tiles 2, 6, 5, 4 are moved to either left direction, that is 6 can be moved to left direction, right direction 4 can be moved to right direction, up direction 5 can be moved to up direction, down direction 2 can be moved to down direction. Okay, next one. The initial arrangement is called as initial state and the goal arrangement is called as goal state. Okay, whatever the initial arrangement that we have to take it, that can be called as initial state. Okay, whatever the goal state that we are obtained at the last, that state can be called as goal state. So this is the goal state and this is the initial state. Next one. The state space tree for 8 puzzle problem is large because there can be 8 factorial different arrangements. A partial state space tree is shown in below figure. Okay. So the states, our main objective is to construct the state space tree for a given problem. Okay. Now the state space tree for 8 puzzle problem. The state space tree for 8 puzzle problem is very large because there are how many number of cells are there? How many number of tiles capacity is there? 9 tile capacity square friend is there. Okay, so here in this place we have to place how many number of possibilities of tiles can be we have to place. Either first tile we have to place, second tile we have to place, third tile we have to place, fourth tile we have to place, fifth tile we have to place, sixth tile we have to place, seventh tile we have to place, eighth tile we have to place. Okay, how many number of possibilities are there? In this way, there are 9 factorial different arrangements are possible. So it is very difficult to draw the 9 factorial arrangements. Okay, so because of that reason, only a partial state space tree is shown in below figure. Okay, so the state space tree for 8 puzzle problem is very difficult to design because it generates how many number of arrangements are there. So 9 factorial different arrangements are possible because 9 cells are there. In each and every cell we have to assign 8 tiles. Okay, so because of that reason 9 factorial different arrangements are possible. Only because of that reason a partial state space tree is shown in below figure. Okay, next one. In the state space tree the nodes are numbered as per the level. Okay, so in the level 1 only root node is there. Root node is called as node 1. Okay, what are the different directions are possible for node 1? That nodes are numbered from second to how many number of nodes are there in the level 2. So according to the level we are giving the numbering of nodes from level 1 to how many levels are there. Okay, next one. Each next move is generated based on the empty slot position. Okay, based on the empty slot position. So this is the empty slot position. So next moves are generated. Either it is a down move, or it is a right move, or it is a left move, or it is a up move. Because the empty slot can be moved to up direction, or down direction, or right direction, or left direction. Okay, so each next move is generated based on the empty slot position. So based on the empty slot position, we can say that what are the next moves are possible. Okay, next one. Edges are labeled according to the direction in which empty space moves. Okay, here this is empty slot. So based on the movement of the empty slot, okay, what are the directions are possible? Okay, that directions can be named as down, right, left, up. That means edges are labeled. Edges are labeled as down direction, right direction, left direction, up direction based on the movement of the empty slot. Okay, next. The root node becomes the E node. Okay, the first in the state space tree starts with a root node. So that root node becomes the E node because its childs are generated. Okay, next one. We can decide which node to become an E node based on the estimation formula. Okay, so in the next level, what node becomes the E node, that can be generated by the estimation formula, that is the C cap of x is equal to f of x plus g cap of x. This is the formula we have to use. What is the next node in the next level becomes the E node. Okay, C cap of x is equal to f of x plus g of x. where C cap of x is the lower bound node of a lower bound cost of a node x. Okay, f of x is the length of the path from root node to node x. Okay, next one, g cap of x is equal to number of non-blank tiles which are not in their goal position. Okay, for example, what is g of x for this one, this node? Okay, here one is compared to the, this is the goal position, this is the present node x, one is compared to one, both are in the same position, it is the correct position. 2 is compared with 2, both are in the correct position. 3 is compared with 3, both are in the correct position. 4 is compared with 4, both are in the correct position. Here fifth is there, here fifth is not there. So this is the wrong position. Okay, sixth here is there, sixth here is there, both are in the correct position. 7 is there, 7 is there, both are in the correct position. Here 5 is there, here 8 is there, both are not in the correct position. That is second error. Next, here 8 is there, here 8 is not there, so both are not in the correct position. So g of x is equal to 3. Okay, so 3 minus 1, that is 3. Okay, 3 minus 1 we have to take because one empty slot is there. So because of that reason, so g of x is equal to 2 for node 4. Next, f of x is the length of the root node to this node x. So what is the length? Here this node is there in the level 2, this node is there in the level 1. What is the difference between them? 2 minus 1, that is equal to 1. So now C cap of 4, this node, C cap of 4 is equal to length of the path from root node to this node. What is the length? 2 minus 1, that is 1, plus how many number of wrong positions are there? 3 wrong positions. 3 minus 1 we have to take. So that is 1 plus 2, that is equal to 3. C cap of 4 is equal to 3. So in this way we have to calculate the cost of a node x. Okay, next one. So this is the part of the state space tree for 8th puzzle problem. This is the initial arrangement. Initial arrangement is there in the at the root node. So this is the root node and it is also can be called as node 1. Okay, next one. So this it becomes the E node. Okay, then what are the childs we have to generate it? Node 2, node 3, node 4 are the childs of node 1. Among this node, which node becomes the E node? That can be calculated by using this formula. So these are the lower bounds of each and every node x in level 1, level 2, level 3, level 4. Okay. Now, how we are writing this state space tree? Okay, this is the initial arrangement. So initial arrangement is there at the root node. This is the root node. It can be called as node 1. Okay, this is the initial arrangement. Next, so this is the empty slot. This empty slot can be moved to up direction, right direction and down direction. But there is no possibility of left direction. Only what are the possible direction? That is up direction. This is the up direction. This is the right direction. This is the right direction. This is the down direction. Okay. So there is no possibility of up direction. So for this node, how many number of childs are there? 3 childs are there. That is node 2, node 3, node 4. Okay. So we can go for up direction. The empty slot can be moved to up direction. So empty slot can be moved to this position and one can be moved to this position. So one can be moved to this position. Empty slot can be moved to this position. Remaining tiles cannot be changed. Okay. Next one. Down direction. Suppose this empty slot can be moved to down direction. 7 can goes to up direction. So 7 can be goes to up direction, empty slot can be moved to down direction. The remaining tiles cannot be changed. Okay, now we go for right direction. Empty slot can be moved to right direction. Fourth tile can be moved to this position. Empty tile can be moved to this position. Fourth tile can be moved to this position. Empty tile can be moved to this position. Okay, so this remaining tiles cannot be changed. So this is node 4. Okay, next one. Now we go for next level. So this is the now node X. This is the node X. So what are the possibilities of moving the empty slot? So empty slot can be moved to right direction. Empty slot cannot be moved to up direction. Empty slot cannot be moved to left direction. Empty slot can be moved to down direction. Suppose empty slot can be moved to down direction. So the parent node becomes. So because of that reason, so down direction cannot be taken. Because so whenever we are moving the empty slot into down direction, the same node we are getting. Because of that reason, we are not considering the down direction. Only up cannot be considered, down cannot be considered, left cannot be considered. Only right direction is possible. This is the right direction. So the empty slot can be moved to right direction. 2 can be moved to this place. Empty slot can be moved to this place. So 2 can be moved to this place. Empty slot can be moved to this place. The remaining tiles cannot be changed. Okay. Next we go for this one. So the empty tile can be moved to up direction. Okay. The parent node becomes. Okay. So because of that reason, up direction cannot be considered. Okay. Empty slot can be moved to right direction. Empty slot can be moved to down direction. There is no possible. Empty slot can be moved to left direction. There is no possibility of moving left direction. Only right direction is possible. So empty slot can be moved to right direction. Fifth tile can be moved to this position. Empty tile can be moved to this position. So this is we are getting empty slot cannot be moved to up direction because empty slot can be moved to up direction. So node 1 we are getting. Because of that reason we are not considering the up direction. Okay. Next go to node 4. Okay. So for this node 4 the empty slot can be moved to up direction, down direction, left direction and right direction. 4 possibilities are there. Empty slot can be moved to left direction. So then we are getting the node 1. So because of that reason, left direction cannot be taken into consideration for node 4. So the remaining direction down, right, up. Okay. Suppose empty slot can be moved to down direction. Fifth tile can be moved to this place. Empty tile can be moved to this place. Fifth tile can be moved to this place. Empty tile can be moved to this place. So the remaining tiles cannot be changed. Okay. Next one. Empty tile can be moved to right direction. Sixth tile can be moved to this place. Empty tile can be moved to this place. So sixth tile can be moved to this place. Empty tile can be moved to this place. So it becomes a node 8. The remaining tiles cannot be changed. Next we go for up direction. The empty tile can be moved to up direction. So second tile can be moved to this place. Empty tile can be moved to this place. Empty tile can be moved to this place. Second tile can be moved to this place. Okay. So these are the nodes in level 3. So that is node 5, node 6, node 7, node 8, node 9 are there in the level 3. Node 2, node 3, node 4 are there in level 2. Only node 1 is there in level 1. Okay. Now go for node 5. Okay. So this is the empty slot. Empty slot can be moved to left direction, right direction and down direction. There is no possibility of up direction. Okay. So suppose empty slot can be moved to left direction. Okay. So 2 can be moved to this place. Empty tile can be moved to this place. the parent node we are getting. So because of that reason, left direction cannot be taken into consideration for node 2. Next, what are the remaining directions? Only right and down. Okay. So now empty slot can be moved to right direction. Node tile 3 can be moved to this place. Empty tile can be moved to this place. So remaining tiles cannot be changed. We are getting node 10. Next, empty tile can be moved to down direction. So this empty tile can be moved to down direction. Fourth tile can be moved to this in this place. So this is we are getting node 11. Remaining nodes cannot be changed. Okay. Now we go for node 6. Okay. So this is the empty tile. Empty tile can be moved to up direction, left direction, right direction, and there is no possibility of moving into the down direction. Okay. So suppose empty slot can be moved to up direction. Fifth tile can be moved to this place. Empty tile can be moved to this place. The parent node we are getting. So because of that reason, for node 6, there is no possibility of getting left direction. Okay. Remaining is up and right directions. Down it is not possible. Okay. Up direction, empty tile can be moved to this place. Fourth tile can be moved to this place. Empty tile can be moved to this place. Fourth tile can be moved to this place. The remaining tiles cannot be changed. This is node 12. Okay. Next one. Right direction. Empty tile can be moved to this place. Eighth tile can be moved to this place. Empty tile can be moved to this place. Eighth tile can be moved to this place. Empty tile can be moved to this place. The remaining tiles cannot be changed. This is for node 13. Remaining tiles cannot be changed. Okay. Now go for this one. Node 7. Okay. So this is the empty tile. Empty tile can be moved to up direction, left direction, down direction, right direction. There is no possibility of getting down direction. Okay. So empty tile can be moved to up direction. So 5 can be moved to this place. Empty tile can be moved to this place. We are getting the parent node, node 4. So because of that reason, up direction cannot be taken into consideration. Down it is not possible. Only left and right. So suppose empty tile can be moved to left direction. So empty tile can be moved to this place. Seventh tile can be moved to this place. Empty tile can be moved to this place. Seventh tile can be moved to this place. The remaining tiles cannot be changed. This is node 14. Okay. Next one. So empty tile can be moved to down right direction. Eighth tile can be moved to this place. Empty tile can be moved to this place. Eighth tile can be moved to this place. Empty tile can be moved to this place. Now this is the goal arrangement. Okay. What is the goal arrangement? This is the 1, 2, 3, 4, 5, 6, 7, 8. Last empty slot is there. Whenever we are getting the goal arrangement, we have to stop the extending the node. Okay. Now we have to stop. So for this is the initial arrangement and this is the goal arrangement. Once we are getting the goal arrangement, we have to stop the extension of node because it is a part of the state space tree for 8 puzzle problem. Okay. So in this way, we have to draw the what are the possibilities of movement of empty slot for a given node X, either in up direction, right direction, down direction, left direction. Okay. Now, how we are find out the cost of a node X? Suppose for this node we have to calculate the cost. Okay. So C cap of 1 is equal to, so length of the path from root node to node X. This is the root node and node X is also same. So because of that reason, cost is 0 plus 0 is f of x is equal to 0. 0 plus g of x. So g of x means how many number of non-blank positions are not there in their correct position when we are comparing to the goal position. Okay. So this is the goal position. This is the node X. Okay. How many number of wrong positions? 1 is there in the correct place. 2 is there in the correct place. 3 is there in the correct place. So 4th is not there in the correct place. That is 1 wrong position. Fifth is not there in the correct position. That is second wrong position. Sixth already there in the same position. Seven is there already in the same position. So eighth is not there in the correct position. That is the third wrong position. Here this is the wrong position. That is fourth wrong positions. So 4 minus 1 we have to take in. So that is 4 minus 1 is 3. This is g cap of x is equal to 3 and f of x is equal to 0. 0 plus 3 is equal to 3. So cost of node 1, c cap of 1 is equal to 0 plus 3, that is equal to 3. Okay, next one, cost of node 2. Okay, so node 2, c cap of 2 is equal to length of the path from root node to this node. So this is level 2 and this is level 1. Difference between them is 1. That is the length of the path from root node to this node is level 2 minus level 1. 2 minus 1, that is 1. F of x is equal to 1. Next, how many number of wrong non-blank positions that are not in their correct position when we are comparing to the root node? So here 1, 1. So here 1 is not there. This is the wrong position and this is the correct position. This is the correct position. This is the wrong position. 2 wrong positions. This is the wrong position. 3 wrong positions. 6 already there. 7 already there. So this is wrong position. This is wrong positions. So total 5 wrong positions. 5 minus 1, that is 4. So 1 plus 4, that is equal to 5. Okay. Now we go for this one. How many number of wrong positions are there when we are comparing to the goal position? First, c cap of 3. This node is c cap of 3. Length from root node to this node is 2 minus 1. That is 1 plus how many number of wrong positions? 1, 1, same. 2, 2, same. 3, 3, same. 7, here 4 is there. Wrong position. 4, 5, wrong position. 6, same. Up to now, 2 wrong positions. So this is third wrong position. This is fourth wrong position. This is fifth wrong positions. 5 minus 1, that is 4. 1 plus 4, that is equal to 5. Okay. So in this way, so next we go for fourth node. Okay, c cap of 4. C cap of 4 is equal to length from root node to this node is, so level 2 minus level 1, that is 1. So 1 plus how many number of wrong positions are there? Here 1, 1, same. 2, 2, same. 3, 3, same. 4, 4, same. Here the first wrong position, same, same. Second wrong position, third wrong positions. So 3 minus 1, that is 2. 1 plus 2, that is equal to 3. Okay. Now go for this one. This node is node 5. So node 5. How many number of length of the path from root node to this node? This node is there in level 3. This node, root node is there at level 1. 3 minus 1, that is 2. Plus how many number of wrong positions are there? So how many number of wrong positions? First one, wrong position. Second one, wrong position. Third, same. Fourth, wrong position. Fifth, wrong position. Sixth, same. Seventh, wrong position. Same, correct position. Eighth, wrong position. And this is also wrong positions. Total 5. So 5 minus 1. Total 5, 5 minus 1, 4. 2 plus 4, that is equal to 6. Okay. So in this way, we have to calculate the cost for each and every node. Okay. Now we go for node 15. Okay. So node 15 cost. Okay. So length of the path from root node to this node x. So that is, this is in level 4 and this is at level 1. Root node is there, level 1. 4 minus 1, that is 3. 3 plus how many number of wrong positions? 1, it is correct position. 2 correct position. 3 correct position. 4 correct position. 5 correct position. 6 correct position. 7 correct position. 8 correct position. All are in their correct position. So g cap of x is equal to 0. So 3 plus 0 is equal to 3. Whenever we are getting g cap of x is equal to 0, then we have to stop the extension of the procedure because we are getting the goal arrangement. Okay, so this is the 8th puzzle problem introduction. how to calculate the cost of each and every node, how to calculate the C cap of X for each and every node, how we are getting initial arrangement to goal arrangement. Okay, so thank you for watching this video. If you like this video, please share this video to your friends and classmates. If you like this video, please subscribe my channel name. So Divvela Srinivasarao. Divvela Srinivasarao. Thank you.